Here we go. Today is Sunday, January 14th, 2018. And this is episode 209 of the Defensive Security Podcast. This is Jerry Bell, and joining me tonight, as always, is Mr. Andrew Callett.
Good evening, Jerry. How are you tonight, sir?
I'm good, and Happy New Year. This is the first episode of the new year.
Yes, sorry for not getting one last weekend, but we were both in cold, frigid Michigan.
Siberia. It's like
Siberia.
Yeah.
Dealing with not very fun stuff, but we made it through, and now we're back.
That's right.
Now we're back. So Happy New Year to you, too.
Thank you. And just a reminder, the thoughts and opinions expressed on the show are ours and do not represent those of our employers. And once again, thank you to all of our Patreon donors. I do sincerely appreciate you. One more thing, Andy and I will be at the Tactical Edge Conference in, I think it's the second week of March, down in Bogota, Colombia. It's tacticaledge.co. Be there, be square. Both Andy and I are giving talks. So,
in fact, I just shot a 30-second promo video as requested by the organizer. Have you gotten your video done yet?
I have not. It has been a heck of a weekend.
Yeah.
Weekends for me are like work days, except I have less conference calls. So.
Wow.
Yeah. Anyway, there you have it. And by the way, we often record podcasts, so there's that too.
Yeah, we do occasionally.
Yeah.
Try.
Yeah.
I mean, not that we've been that regular lately, but we're trying to add more fiber to the diet and it'll get better. All
right. So yeah, there's not been a whole lot happening this year. It's been kind of quiet on the IT front, right? Not a lot going on. So it was a little difficult to find stories, but we found some. The first story comes from CSO Online, and the title is 5 Mistakes I've Made and How to Avoid Them. And so this is from an author who apparently specializes in developing security awareness programs. Apparently his former employers include Disney, Sony Pictures, Activision Blizzard. I can't wait for Activision Blizzard to buy some other game company so their name just keeps getting longer and longer. But anyway. So first, his first observation is, I guess you would call it a regret, is trying to turn my employees into human sensors. And, thinking about confirmation bias, this one kind of resonated with me because he's basically saying that, the way I like the way he put it, he tried to program his employees to be sensors like a sim, and that's really not a winning proposition here. So, his net point is, if you don't want people to pick a bad password or reuse a password, why would you give them the ability to do that? And I think you can expand the concept out quite a lot from there, in that, if you don't want people to click on the wrong email, make sure the bad emails don't get to them, or the harm that can happen from them doing that is mitigated somehow. So, you can't completely rely on people recognizing that something bad is facing them in the face, or staring them in the face.
Yeah, we've talked about this a few times, and I completely agree with this point here that I think the whole concept of security is everybody's responsibility, and awareness and training and trying to get your folks to be, by folks I mean non-IT security folks, deeply into this. It doesn't hurt, but I think it's a false sense of security. I think, if you can train them to see something weird and say something, great. But if that is your primary line of defense, I think you're asking for trouble. And I think I would rather assume that my users are going to get tricked by sophisticated situations, because that's what those situations are designed to do, is trick users. And they're not stupid. He says in here, one of his favorite things was, you can't fix stupid, and that he'd bought into the negative image, users are stupid. And I used to kind of have that arrogance, and I don't think that anymore. Now I think that they spend their time worrying and caring about different things than what we care about. And so our expertise, our experience is not their experience. And they might think of us as stupid in accounting or stupid in logistics and marketing or whatever.
Yep.
Right. So it's a different, certainly there are some dumb people in the world, but I'm just saying, take the 80 percentile. We are expecting those folks to not only do their job they're paid for, but also our job.
Right.
And I think that probably is not a winning proposition.
Yeah, exactly. So his second regret was pushing the company agenda. And I'd net this one out to say that when you go into a company, the senior leaders of the team or of the company all have their opinion on what security awareness means. And he apparently in the early days of his career would kind of embrace that and go execute on that versus doing what he thought was right. So next was not building a community and using guides. So I thought this one was a little interesting, and I suppose it's probably more apropos for larger companies. But the point here is that within companies, there's a lot of there's a lot of little cliques and sub-communities that form around different things. So, whether it's technology or some type of function, leveraging those existing communities to get your messages out rather than trying to build something new. And I really like the one of the points here, and this kind of resonated with me from some previous jobs I've had. Sending out emails to employees from email accounts that are strange or things that they've never seen before, and expecting them to honor it, versus trying to find what I'll call the centers of power in the company, and not the leadership, but maybe administrative assistants and office managers and stuff people like that, and leveraging those people to get your message out. So I thought it was a good idea.
Yeah, it's interesting. I think this also speaks to a CISO can't operate as an island. If he doesn't make good relationships with the folks who can really influence, he's going to be in trouble. No matter how right his message is, if he's not communicating well and communicating effectively, it's a very difficult job all around. But that is, if you take that one point out in isolation, you can be the most technically astute person, but if you cannot work well with your peers, they have all sorts of ways of stymieing you and making you unsuccessful.
Yeah, absolutely. Number 4 was focusing on the wrong metrics. And boy, I've seen this a lot, and I've fallen victim to this too. And he points out
that I could rant on this one for days.
Everybody likes to have metrics, right? And I think a lot of times we fall into the trap of trying to provide what's easily accessible. And so the 3 that he calls his top 3 metric missteps are: number 1, phishing training click rate, which kind of negates a whole lot of external factors like vacations and time off, and what might be happening in the news and all sorts of other things. Which, by the way, should tell you if you've got a factor for those kinds of things, training is probably not the end all, right? Because if people can be influenced by those kinds of factors, it has limited effectiveness. Next is measuring the newsletter / email read rate. So when you send out your periodic communication with security goodness, and you're trying to measure how many people read it. That's, as he points out, is often more a referendum on how well you write your emails than how engaged your employees are. Which, by the way, by itself may be an interesting metric, right? If I'm not doing a good job of creating engaging content, that's something probably worthwhile to measure. And then annual training completion rate. And this one was a little. I mean, so if you have mandatory training, right, and people can't get away from taking the class, I guess at some level you have to track it. Otherwise, it's not going to be mandatory because people will evade it, right?
So, but showing it as a metric for the success of your security program is probably not great.
I agree with that. He goes on to point out that he thinks a better metric is trying to measure the extracurricular learning that employees do, and I guess I can see that, but I just he shows the example of being able to show leadership that 500 plus hours were spent by employees voluntarily learning.
Well, I'm assuming he's talking about learning about security issues.
Yes.
But that kind of goes back to his first point of don't expect your users to be your sensor.
Right.
Right. I mean, it doesn't. Well, I can't say it doesn't hurt because every resource in an organization is finite. So if I'm taking away 10 hours in a week to train about phishing, that's 10 hours that employee, in theory, could be doing something else productive for the organization.
Yeah. Unless you're going to mandate they do it on their own time.
Yeah. That has its own issues that I think certain states would find that illegal. Man, you are an executive.
It happens, man.
If I'm working Christmas, you're working Christmas. But at the end of the day, how do you show effectiveness of these campaigns is what I've always struggled with. How do you show what would have happened if they hadn't spent that time on that? How do you do the sunk cost analysis? I don't know. But the other thing I would say about the metrics is I've also worked in organizations where the metrics were dictated to the security organization by non-technical folks. In other words, show us these metrics. That, I think, is a huge problem, too. I think what the better approach is, okay, external risk group, what are you trying to measure and why? Okay, let's work together on defining the appropriate metric out of the appropriate tool set, or, and let me show you how I take the raw data and massage it to get you what you need so that you're telling the right story. I've seen so many times where the nuances of raw metrics being sent around organizations causes nothing but chaos. And if there's anything that I could take out of this is negotiate with your folks who are consuming these metrics what and why and how to make sure that the correct information is being sent. The other problem with metrics is as soon as you start measuring people on metrics, people will start gaming metrics. Mm-hmm. And that is another area you really have to watch for. So, if the security organization, for instance, is reporting metrics on, let's say, patch rates, you have to be very, very careful if you're in executive leadership, who you hold accountable to that patch rate. Mm-hmm. If you hold your folks who are gathering that data, in other words, the vulnerability management tool being run by a certain team, and yet they're also held accountable to the patch success rate, that's going to go badly for everybody. It's going to cause perverse incentives to not report all the vulnerabilities because they get hit if the system owners or whomever don't patch. So anyway, point being, how you measure and react to metrics is a huge deal. So whenever I'm asked for metrics, I always want to know, what do you plan to do with this and why? Not that I want to hide anything, but I want to be able to action the appropriate decision-making with the right folks.
Yep. Well, I mean, at the end of the day, metrics should be intended to drive some behavior change based on the value the metrics come out as. Typically,
spending this much time talking about metrics drives people to fall asleep.
Yeah, that's true. So moving on. Number 5, not separating training from awareness. And
I'm aware that we have training.
He points out that training is things like your annual awareness training the mandatory either classroom presentation or web-based presentation, or your phishing education or your privacy education, versus awareness, which he calls things like ambassador programs and the National Cybersecurity Awareness Month events, and creating engaging content like funny videos. And I've talked about in the past, and Delta has stopped doing this, much to my disappointment.
They heard you talking about, they're like, screw Jerry.
Yeah, seriously. It wasn't long after I started talking about it, they canceled it. But, Delta used to have, as part of their safety videos before you take off, it was a funny little skit, and they had a bunch of different versions of it, and so it was kind of entertaining to look for the nuances. So finding some way to make things engaging is good. Culture assessments, simple policy one sheets or one pagers, I guess, is what I would call it. And I think that's, by the way, really important, because if you plunk down 1,000-page policy in front of someone, it's kind of like telling them, don't break the tax code.
Yeah, which goes back to the first point. If you expect your users to know and follow all the nuance of your policy, you're in trouble already. You've got to put up some technical guardrails,
right,
to keep them on policy.
Right, and then finally, role-based training, like high-value targets, developers, that sort of thing.
So, like, naughty secretary.
Yeah, exactly.
And overbearing boss.
Exactly. French maid, the whole 9 yards. Yep.
Or is it more like, roll a d20?
Gorilla suit. Yep.
Okay.
Anyway,
yeah.
Moving on. Next story comes from CSO, and the title here is "Why We Continue to Fail: Lessons Learned from the Atlanta Airport Fiasco." So, shortly after the new year, the Atlanta Airport, which is, as far as I know, still the largest airport or the busiest airport in the world
by passengers,
had a really horrible problem. Their power went out for, I don't know, 6 or 8 or 9 hours. I don't know exactly how long it was out. And what ended up being the cause is that they have redundant power feeds, and they have power generation, but the power feeds all shared apparently the same underground tunnel at one point.
Sure.
And there was a problem with the main feed, I guess, caught fire in one of the tunnels, and because they were all in the same tunnel, the power flipped over. But in the meantime, things were burning out of control, and so effectively they lost all of their backups. And what happened after that was just chaos. And being here in Atlanta, we got to see a lot of this on the news. The reaction of the airport and the airline employees seemed less than one might have hoped, I guess, and that's kind of the point here.
Yeah, well, just to be completely accurate, the newest terminal, the F terminal, still had power, but it was built many years after the other 5 terminals.
Okay, fair enough. Yep.
And so its power feed came from a different direction and through different tunnels. And yes, the other, basically the backup lines came through the same underground tunnels, and that underground tunnel was very difficult to reach for the firefighters. So it was kind of a perfect storm of badness, tied with a whole lot of assumptions, bad assumptions around failure conditions. Mm-hmm. And it was ugly, because this had never happened before. Not really. I don't think Atlanta Airport has ever lost power like this. ATC, the tower and whatnot, still had power, but all the concourses were down except for F. So it was ugly. And now, before we get into the story, I will tell you, trying to anticipate every possible failure condition and having a plan and having all your folks trained and remember that plan for every possible situation is not viable, right? And so it's really easy to look back in retrospect with 2020 hindsight and say, this screwed up, this went bad, they should have done XYZ. But keep in mind, there's only so many disaster recovery scenarios that your folks can hold in their head at one time. So as we get into this, this guy's advice is often, well, should have trained him on this, should have trained him on that. Okay, for one discrete scenario, sure. But how many different scenarios can you encompass?
Yeah, so I think there's two ways to read the story. One is a critique of the airport, and the other is a way to think about your own recovery programs and where you may have blind spots and need to make improvements. So I think that's the more interesting perspective for me. But there certainly are some, I think some trouble points with what's written here. So his first point is lack of a coherent, acceptable, and tested business continuity and disaster recovery plan. And he points out that the tower, like you said, still had power, and so they were able to issue a ground stop and whatnot, but everything else kind of ceased, and there wasn't at least apparent coordination between the Georgia Power and Delta and the airport. Again, we don't exactly know what happened, but but the appearance is it was not really a coordinated response.
Yeah, they had no way of very easily getting folks off of planes who were stuck on planes for up to 5-6 hours. There was a lot of confusion and lack of coordination, lack of leadership around what to do and how to handle the situation. That's for sure. It seems like everybody was just lost and kept expecting the power to come back any moment and couldn't conceive of a 10-hour, 12-hour outage.
Yeah, exactly. So he points out that when you're creating your business continuity DR plans, you should remember the acronym PACE, Primary Alternate Contingency Emergency, and kind of in an escalating response scenario. And I think, by the way, one thing you mentioned, I want to come back to that, and that's that I think people were really expecting this to be a short-term thing, and that just kept dragging on and on and on. So
yeah, I mean, nobody knew the extent of the situation early on, and anytime power had ever even blipped before, it had been back in seconds at the airport. So, and no one knew this was going to be an extended outage when this happened.
Yeah. So number 2 is train as you fight. So his background is as a soldier, and his point is that you should have a documented business continuity and disaster recovery plan that your employees have trained on and know how to implement. And he points out that the employees appeared to have disappeared, or at least the reports from passengers in the airport at the time were that the employees just kind of disappeared. And I remember seeing the news reports, and that certainly seemed to be the case. That the terminals were dark and it just seemed pretty chaotic. And it got me thinking. His assertion here is that the employees were probably off trying to find management to figure out what they should do because they didn't have a disaster recovery plan. But I got to wondering, what do you know about airport passengers?
They're very reasonable and patient people.
Yes, exactly. When things don't go well, airport passengers can get quite rude. And I got to wondering, how likely is it that, as time went on and, the employees started to realize that this was not going to be a short thing, you just don't want to deal with it, right? I mean, because I would imagine we're all human. I mean, they're all human. We're wired to avoid pain and suffering. If you know that you're going to walk out and you're just going to get, you're going to get crap from employees. I'm not saying that's why, but it got me to wondering, from a disaster recovery perspective or business continuity perspective, how much of our plans rely on the the fact that our employees are actually going to be there and engaged to execute the plan. And
right.
Depending on the scenario, that may be the case, but it may also not be the case.
Yeah, that's a good point. Especially in terms of like a pandemic or some sort of major issue where you've got a lot of folks out, which is part of a lot of DR plan.
Right. Or they just don't want to do it because people are going to get mad at them and they don't want to they don't want to deal with it.
At the same time, how much energy and money and time and resources can you devote to 0.5 percentile events?
Yeah. I mean, that's a good point. The airport's been there a long, long time, and they've not really had this sort of an issue before.
Obviously, they need to here, but if I abstract this back away to corporate America and to security and DR and such, there's got to be the right level of effort to spend on whatever your likely DR event is. And as you start listing out your events, you eventually get to a point, I would think, that event falls below some threshold of unlikeliness that it no longer makes sense. You make the risk decision. If this were somehow to happen, we're just going to have to wing it because we're not going to spend the time, energy, and money to develop and train and test for that sort of situation. Mm-hmm. But then again, your DR plans might be very simplistic but cover many things. Like you've got 2 geographically dispersed data centers, you can fail between them, all of your applications, something like that. And then it doesn't matter necessarily what happens per se.
Yeah, when I design DR and business continuity plans, I like to think about it as like trying to build a box of parts, right? That can be put together based on the particular scenario, rather than trying to kind of predict a bunch of different scenarios. Try to predict a couple of different common themes that would have to be implemented across a really diverse set of scenarios, and then create a small set of plans that are applicable to that can be tested. And by the way, it occurs to me, and we don't really know that the airport didn't have a plan around power outages. We just don't know that. Seems to be a hypothesis of the...
Yeah, they might have had a great plan that just didn't execute, or
right.
whatever.
Yeah,
we don't know.
Exactly. But, the certainly the optics are that they had, that they had all this redundancy, and therefore they didn't really need to have a plan for power outage, and that it was some, really, really unlikely event. But, it's a power outage. It's not an unlikely event. It happens. And in the context of an airport, especially a really busy airport, in an extended power outage scenario, you got, I don't know how many planes were out on the tarmac full of people, and they were stuck there for many hours. But and that, by the way, is one of the critiques of the author here, is that people were stranded out there. But I wonder, what's the alternative, right? The alternative was to drive those mobile stairs up, which would itself take hours and hours and hours to get to all of those airplanes. And then what are you going to do? Bus them to terminals that are already full of passengers with no power.
Right.
So,
but also nobody was communicating anything.
Well,
that's a big part of the problem, is that
yes,
there was no information being given to any of the passengers. I mean, we're a little far afield. I think if you bring it back from the airport's perspective, they had primary and secondary power. They had a failure of imagination to consider that both could be knocked out in the same incident.
Right.
Because they came through the same conduit lines, basically not the same line, but the same tunnel right next to each other. And when that fire took them both out, obviously they couldn't fail over to their secondary because their secondary was gone too.
And you know what kills me? Somebody somewhere along the line accepted that risk.
Probably. Whether they knew it or not.
Yeah. Yep.
And so for me, that's the big takeaway is what other risks like that are we accepting that we are not realizing?
Mm-hmm.
What assumptions go into our DR plans and go into our contingencies?
Yeah, right. Or our failover, so we have hot failover, and we're pretty comfortable that it's going to work.
Right, but, and because this has never happened before, it normalized the risk.
Yeah. So next on his list is communication, and he points out that when the power goes out, you lose your you lose your ability to charge your cell phones, your walkie-talkies, your voice over IP phones. You can't send email, on. And so he points out that when that kind of thing happens, you really need to establish a command and control center. And I think that's a pretty fundamental disaster recovery, business continuity concept, which makes good sense. And it's unclear if that happened here. It certainly, if it did happen, I think the one thing that he could have thrown rocks at here that he didn't was your point that nobody was communicating with the customers.
Yeah, nobody knew what to tell them because nobody knew what was going on.
Right, and so that seems like a big lesson there is you really need to have people who are off trying to get to gather situational awareness, and then passing that up the chain so that the proper communications can be crafted and then disseminated. Delayed reaction time is next. I think we talked about that one a lot. He talks about here the planes on the tarmac for between 5 and 11 hours. That there was a story about a plane that had landed from coming in from Amsterdam, so it was a 10 or 11 hour flight already, and they landed right as the power went out.
Oh, that's unfortunate.
And then they were on the plane for another 5 or 6 hours.
Welcome to America.
Yeah. That's a long time on a plane.
And then once they finally get out of there, they still got to go through customs.
Right.
And immigration.
Right. And no bags. And there was no, obviously all the hotels were probably booked because you had just a, sea of humanity. And then last is infrastructure upgrade. And by the way, I take a little exception to this one because I think there's an assumption that the infrastructure was poor and that's what led to this problem, and I'm not sure that's actually the case. I think all
infrastructure has a failure rate.
Yeah, what led to this was some bad decisions, in particular about using the same underground tunnel to run main and backup power through. So if you upgrade your infrastructure and you make that same mistake, what have you got?
I don't know if it says anything about just the Twitter communities I follow, but I remember when this happened, a whole bunch of people jumped to the terrorist attack, cyber attack conclusion immediately.
Oh, and absolutely.
Clearly that wasn't the case, so let's not cry wolf too often there.
Yeah. So and then the last thing we have for today is this little obscure story that I happen to hear about. Nobody's probably heard about it. It's about these vulnerabilities in microprocessors. One's called Meltdown and the other's called Spectre.
Never heard of it.
Yeah. Probably haven't. Most people probably haven't heard of it.
Is it worth spending time on this?
I don't know. So, this is a really interesting dumpster fire for a couple of reasons. On one dimension, Google's Project Zero discovered this and reported it to a couple of different companies back in June, and they embargoed it, which, by the way, is like far longer than I think they've ever, as far as I know, done in the past. And it was scheduled for disclosure on January 9th, which I think probably was intended to give IT people the holidays off.
Right.
But what ended up happening is that this started leaking out sometime around Christmas time, and and the drum beat kept getting bigger and louder, and eventually it was released publicly, I think on the 3rd or the 4th. So here's the long and the short of it. There's 2 named vulnerabilities. There are actually 3 different attack techniques. They all are fundamentally the same in concept. That the implementation details are a little bit different, but basically, the attack uses the predictive execution features of modern microprocessors to read things that processes shouldn't have access to. And so basically, it's not well known by lay people for sure, but microprocessors, modern microprocessors, in an attempt to be faster, are trying to guess at what you're going to want to execute next. And if it guessed wrong, well, no harm, no foul. It just drops what it did and goes and executes the thing that it should execute. What these researchers have found is that they can actually influence the code that gets preemptively or predictively, well, let's try that again, predictively executed, and actually also not only what gets executed, but the memory on which that gets executed on. And even though ultimately that predictive execution turns out to be wrong and then gets, the results of it get destroyed, the data that it acted on gets pulled into the CPU's cache. And the attack relies on being able to reach into that cache and pull out the data that the predictive execution found. And there's a technique using timing where they can determine if the predictive execution was able to get the memory that they wanted, and therefore it's resident in cache. And so again, there's 3 different flavors of this. One flavor can only work on memory within a process, and then the other 2 are effectively either kernel-based attacks or attacks that can affect the system more broadly across across different user boundaries. So the patch or the fix is, I guess, where the really big problem comes in.
Now, let's also be clear. As of right now, there's the only avenue of attack for this, the only real attack surface is locally executed code in some way. There's no remote code exploit that we know of. There is browser-based exploits. So if somebody is active on the machine and goes to a malicious website, there, I believe, some active proof of concept JavaScript code that can run against this. But there's nothing like an open port on the machine that a third party can attack to make this happen. So
correct.
We have, I'm sure we'll talk about this in terms of the risk of this issue, but because it had a logo and because it had a name and because it got covered in the press,
it's an emergency.
Oh my God, yes. But as big bugs go, this is more of a concern, I would say, on user systems than servers.
Well, with a couple of exceptions, I agree with that.
Well, yes. Well, I'm just saying there's no remote code execution really against this bug, and there's really it's a nasty little piece of work. Don't get me wrong, but I guess fundamentally we constantly do this. We panic over the latest named vulnerability, and don't necessarily measure the risk of that vulnerability and the threat of that vulnerability very well, and react appropriately.
Yeah, that is. I certainly agree with that, and I think that is, in large measure, what's happening on this one. But I think there are a couple of cases where this actually is pretty significant, and the most significant area is actually cloud computing. And the reason is that one of the attack vectors, I'm not entirely sure this has been borne out in a actual test, or if it's still theoretical or what. But anyway, the concern is that it is a local attack, right? But it conceivably provides a virtual machine escape. So the ability to read memory of the hypervisor and potentially memory of other virtual guests on the same system.
Which is pretty heavy.
And so
that's a big deal.
So that I would say it's most significant, most problematic for public cloud providers, where you could have multiple untrusted tenants on the same system. I would say next in kind of descending priority would be private cloud type environments where you might have different types of workloads. Let's say an internal workload and an external workload, and if the external workload gets compromised, it could conceivably provide a way into the internal. You mentioned the workstation based JavaScript exploit, and I think at this point a lot of the web browsers actually have released updates to mitigate that particular attack. But it's as I understand it, at least, all of the mitigations that have been released to date really only make it harder to execute. It's not like they've necessarily completely cut it off.
Yeah, because we're talking about something fundamental in the hardware firmware of modern CPUs.
Yeah, and operating systems, and it's
a really complicated situation with this one.
It's bad design choices that happened a long time ago, 20 years ago.
I don't know. I guess speed. This was a trade-off for speed and efficiency, and I get that. You've got a lot of spare CPU cycles where we're waiting for something else to get done. How do you make use of that? Well, you start predicting.
I certainly don't think that predictive execution is the problem. I think it's they implemented it without any safety net or guardrails.
Yeah, it should have been because fundamentally this should never have been available to other processes. But
right,
yeah,
right. So anyway, here we are. This is a really interesting one. I think this kind of goes into a special category along with Heartbleed and Shellshock, and to some extent Poodle. I actually think it's in many ways more like Poodle than anything else, because it's while it's not remote, it provides the ability to read memory, which is effectively not Poodle. That's Heartbleed. Sorry, brain fart. Yeah,
it's all right. You're getting old.
Poodle is for those wondering, Poodle was the TLS vulnerability.
I'm waiting for the Labradoodle vulnerability to come out. That'll be next on the list. But what's also, and I'm sure you're going to get to this, is the impact of the patches. It's not just a simple, hey, apply this patch and you're good to go. Oh no, there's more to it than that.
Yeah, and actually each of the three techniques I mentioned require a slightly different fix. One of them requires actually a hardware, effectively a hardware patch or an operating system patch. The other requires a different kind of operating system patch, and then the third requires changes to the actual applications themselves. Like I mentioned, that web browsers had been recently patched for one of the vulnerabilities. So the big issue, and I would say the main topic of discussion of the industry related to this, is the performance impacts associated with fixing it. And by the way, not only the performance impacts, but I would say the quality of the patches that have been released.
Mm-hmm.
And more than any other vulnerability that I can think of in recent history, this has been an absolute train wreck. Because
I think there's so many downstream impacts too.
Yes. Absolutely.
Like certain fixes for Windows broke a bunch of antivirus software.
Yeah. So
because the AV guys were against spec hooking into this memory in such a way that made their product run faster, but was impacted when they fixed this vulnerability in such a way that they couldn't do that anymore.
And in some cases, some antivirus was causing a patched Windows system to blue screen.
Sure. And then there was also issues on certain AMD processors based boxes or blue screening on certain Windows patches.
Yeah. So what I think part of the issue, and I'm not entirely sure this would have been a whole lot better had the disclosure plan proceeded as planned, because it was disclosed about a week early. But Microsoft pushed out a set of patches, and the patches. This is kind of a hack in my view. The patches rely on your antivirus program setting a particular registry key that effectively tells Windows Update that the antivirus software is capable of running with the newly patched version of Windows.
So it's almost like a compatibility mode for your AV.
Correct. And if if your AV doesn't set the flag, then the patches don't get installed, and you don't get the fix. And
right, because they made the decision it's better to have active AV than break AV.
Correct.
And wait for the AV vendors to catch up.
Correct.
Yeah.
And then so they did release the patches, and then what was discovered is that as you mentioned, older AMD processors were blue screening with when they had the new patches on. So Microsoft changed the logic on the patch applicability. So now that patch does not install itself on. I don't know if it's all AMD processors or just the specific ones that had problems. And then Intel released a microcode update, which fixed one of the issues, but they found that not only does it create a fairly significant performance impact, it actually also causes an increase, what they describe as a, quote, increase in random reboots on certain models of their processors.
So not started random reboots, just increased the frequency. So clearly there was a random reboots going on before that.
I thought it was really oddly worded. It didn't start it. It increased the frequency. So anyway, one of this is hopefully you're getting the sense, if you're not familiar with this, right? This is kind of a circus. It requires patches of your hardware and of your operating system, and in some cases of your application. And there are sometimes prerequisite updates like to your antivirus that has to happen. And by the way, for the most part, your hardware updates are going to come from the manufacturer of your computer, not from Intel directly, unless you're using Linux, which can provide, can upload the microcode updates directly on boot. But Lenovo, for example, released some updates and then had to retract them because they were causing problems. And so it is, I can only imagine this is probably one of the more complicated, as I think about it, I can't think of any other example of a widespread or even not a widespread vulnerability that's been this damn complicated to fix.
But wait, there's more. Now how much would you pay? Yes. So there's all sorts of reports of performance hits.
Correct.
Anywhere from 5 to 30%. I think we're finding it's not nearly that much. But what I find interesting, kind of going off top, kind of wandering down a rabbit hole for a moment here, is so the cloud providers went and patched for this, and a number of their customers started seeing performance hits. So
in some cases, by the way, they patched before this was even like
right.
Publicly known. Yeah.
And in fact, in the story itself, we talk about it opens with a customer of a cloud provider beating their head against the wall for days trying to figure out why their performance had tanked, and they ended up having to spin up more VMs to basically get back to their performance. So what you have here is the cloud provider making the risk versus performance trade-off decision for their customers without really discussing it with them at all, and potentially costing their customers a lot of money, a lot of extra money.
Yep.
So I'm not saying it's a wrong decision. I'm saying it's interesting that we have moved that risk decision. Right? I get completely where the cloud provider is coming from. They got to protect each other, but the cost issue, because you're paying, per whatever quantity of performance that you're talking about based on the various providers. But if suddenly my performance goes down on the same box or the same bit of hardware, the same bit of kit, and I'm expecting a certain level of performance, I don't have to pay more.
Mm-hmm.
So it's not like the cloud providers guarantee you a certain level of consistent performance ad infinitum. And this sort of situation really made me think about that of what if another patch comes along that slows it down by 30%, and that's an interesting problem. If I own the boxes and I own the servers and they're in my data center and I have a really high performance environment, maybe I do stock trades or whatever, maybe I make the decision not to patch until I have a lot more time to vet it. When I've outsourced that decision to a cloud provider, I don't have a say.
Yeah, well,
it just costs me a hell of a lot more money.
Yeah, I mean, let me take the other side. I don't fault a public cloud provider for doing that. I mean, I think it's almost I think they would have had more hell to pay if they didn't take drastic steps. Because if
I agree, I just don't know that we've ever considered this implication.
No, I don't think we have. But so let me play the other side of the physical data center thing, right? So on the cloud side, I absolutely agree, and I actually wrote something up about this yesterday. It was in a fit of creativity. There's pros and cons. So when you have a system in your data center, now let's assume that you, for whatever reason, are hell-bent on applying the patch. That's going to create a performance problem on your system that's probably not unlike the performance problem that you would have if you had the system hosted in the cloud. But the difference is that in the cloud, you can just order more capacity on the same server or maybe another server, and you have that capacity either minutes later or shortly after. Whereas in the physical data center world, if your server is now too slow, you got to go order a new, potentially a whole new server.
You've got elastic capability in that cloud provider, sure.
And then the other thing too is, I know with AWS they've gone through a couple of iterations of patching, but it sounds to me like they patched before this was publicly disclosed, right? How many people, how many data centers, how many private company data centers have the ability to provide, to patch their environment before something is publicly known? It's, that I think that's one of the, possibly, and it's a pro and a con, and I'm not disputing that. But on the other, you can't deny the fact that these cloud providers, because of their the size of their environment and the nature of their business and the relationship they have with hardware vendors, they're going to have early access to this stuff before you as a private company do.
I mean, the reality is that this is really, I mean, I hate to say it like this, but this is really the graphic card manufacturers did this to slow down the bit miners so they can buy more graphic cards. It's really what's going on here.
Well, absolutely, that's right.
It's all about the cryptocurrency now, and this is the cryptocurrency wars that we're going to be fighting for a while that we have to deal with.
Yes, indeed.
That joke sounded much better in my head.
I figured that was going on. Anyway, I think the manufacturers had been in denial. Like Intel had kind of been in denial, or at least downplaying the performance impacts. But they've recently started actually publishing some benchmarks, and Microsoft has published some too, basically saying, if you're running Windows Server 2016 on any kind of processor, you're going to notice a slowdown. They point out that, and actually this was in one of Google's write-ups, that about the Google Project Zero. The way they phrased it was, the micro benchmarks that people are running to try to determine the performance penalties are probably not really giving a real world example of what you're going to see in terms of slowdown, because they're just kind of banging on the particular thing over and over again.
It's not a true simulation of the real world, of all the different bits and pieces working together and all the different bottlenecks, and you're focusing on one particular component of a very complex interaction.
Right. Now, at the end of the last episode, we talked about our predictions for 2018, and I think one of the things I said was that in 2018 we were going to be dealing with a lot of hardware issues, and that certainly kind of came to pass. But here's where I think
is that your polite way of saying I told you so?
Yeah, basically. But so let me I want to ride that wave for just a minute and say, before this issue was made public, the Linux kernel team had been implementing mitigation technology called, I think, kernel page table KPTI. I don't remember what the I stands for right off the top of my head, but anyway, they've been implementing some mitigation, and because it's open source, people were looking at it and there weren't any comments, and so we had a lot of researchers who were not disclosed on this vulnerability trying to figure out what the heck is going on. Why have they done this? And so people were busily trying to reproduce, figure out what the vulnerability they're trying to fix was. And what I guess where I'm going is, I suspect there were a lot of really, really smart people just turning Intel processors upside down, and maybe other types of processors too. And I suspect that continues to this day. And I will almost guarantee this is the beginning of a probably a pretty unfortunate year for hardware problems.
Yeah, we've got a whole new class of bugs to explore.
Right.
And a lot of people will take these ideas, fuzz them, and find other ideas. And we saw it with things like when we started auditing OpenSSH and a bunch of other stuff like that, where one big class of bug or vulnerability prompts researchers to start exploring nearby vulnerabilities or similar vulnerabilities, and we find a whole bunch of new stuff we didn't know to look at.
Yeah.
It seems to always happen that way. Because there's so many undiscovered vulnerabilities out there.
Yes, indeed. So anyway, I like I said, I think we're likely to hear a lot more about this, and I don't think this is the last processor level vulnerability. We by the way, we had a number of Intel, quote, processor vulnerabilities last year. Early in the year, we had the AMT issue. And then in I think October or November, there was the management engine issue. And then I think just earlier this week, F-Secure released another report about a whole other kind of, it was there staring in the face all along, AMT bug, where it would be really, it's pretty trivial with laptops, typically enterprise laptops that support AMT, to boot the laptop up, jump into the AMT configuration, because Intel relies on the OEMs to actually change the password, but apparently nobody does. An adversary who had physical control of your laptop could turn on AMT in a way that gives them access within seconds.
Yay!
Yes. So anyway, I think we are descending into a whole new class of bugs here.
But this is not new either. Well, for data centers, for lights out management ports, there are fundamental weaknesses in a lot of the older code on those lights out management ports are still out there running.
Yeah.
That make it trivial for folks to get into those.
So direct cards. Well, but that's what AMT is, though. AMT is like absolutely. Intel's
same, it's
direct card.
This is, and it's not like these are easy to patch. It's a firmware update,
right?
Because and it's also not easy to detect. The same way that a missing patch in Windows is able to be detected.
Well, exactly. Your system itself is completely blind to what's going on in that context. So anyway, I we're going to be talking about this a lot more this year. And I, by the way, I don't think except for the public cloud thing, I really don't think this is likely to get any significant malicious use, with one caveat. There was a researcher the other day on Twitter who was pointing out that he had leveraged, or he had exploited the vulnerability in such a way that he could very reliably read portions of memory, and he indicated that he was off trying to craft a version of Mimikatz to use this vulnerability, and so it's not a initial intrusion, at least in that context. It's not an initial intrusion problem. It's post-exploitation privilege escalation. And so from that perspective, another concern I have, if this thing doesn't get pervasively patched, is that in the case of NotPetya, God, I am getting old. In the case of NotPetya, we saw Mimikatz being used to pull creds out of memory, right? And that only works in certain kinds of cases where like the user is an administrator and Mimikatz is running as administrator. Well, if Mimikatz is able to run even as an unprivileged user, but has the ability to use the Meltdown or Spectre vulnerabilities to get at the clear text credentials in LSASS, then that's a whole new ball game for people to write automated malware that kind of looks and smells like NotPetya. So,
yay!
Yeah,
I'm gonna open that Orchid farm.
I'm there with you, man. So anyway, we could probably talk for days more. Cloud dangerous. To summarize the article, cloud dangerous industrial control systems, probably vulnerable, probably not going to get fixed anytime soon because they're not terribly exploitable. Google came up with a pretty cool solution they called Reptoline, which is a software solution to a lot of these issues. Cloud providers seem to be iteratively going through their environment, improving some of the performance issues. Let's see what else. Later versions of processors, so newer versions of processors, have less of a performance penalty than others once the patch is applied. And let's see. Other than that, test your patches, my friends, right? I think as an industry, we've kind of gotten, and maybe some of Microsoft's shenanigans as of late has instilled more of a testing discipline. But when these critical vulnerabilities come out, we've kind of gotten into this reflexive mode of, well, just get the patches on immediately.
Yep.
Well, if you do that here, you're going to potentially create a mess.
But that's tough advice. I do think in general sometimes speed to patch is incredibly important.
Yeah, absolutely.
So it's really, you're damned if you damage if you don't on this one. But we even saw this in this article. They talk about how different cloud providers have been rolling out subsequent patches to address this, to tweak the performance hit.
Yep.
And optimize the patch. So there's continual efforts around this issue to make a better patch, which is also relatively rare. Usually it's a patch it and be done with it kind of situation.
Yeah, exactly. And by the way, I wonder, the early on, that a lot of the discussion was amongst people who are far smarter than me, that operating systems can probably do a lot to recoup much of the performance loss just by tweaking the way things work to be more in sync with how the hardware changes. So kind of like, meet me in the middle, and we'll recover most of the performance that was lost. But I gotta wonder, both Microsoft and Intel, and Intel's not the only chip company that's impacted, but I'm just picking on them for a second. How much incentive do they have to continue working night and day to make sure your 5-year-old Intel processor performs as well as it did, last month?
Yeah.
Versus focusing on, the next chip. So I think there's going to be
like if your battery starts to wear out, we'll just have your CPU performance kind of thing.
Wow. Yeah.
Just saying.
Yeah.
Just saying.
Yeah. So anyway,
they're just trying to drive a hardware upgrade cycle. Is that what you're saying? This is like the new Windows or Y2K bug.
I think that's the net effect. I'm not saying I'm not saying they're going into that. They're going into this thinking that's what's going to happen, but I think that's largely going to be the net effect. Is that the optimizations will be the bulk of the time will be spent on optimizing both Windows and other operating systems and the chips in their subsequent versions, not the previous versions. The fix is out there. If you want the fix, it's there. I think the only people who have a major horse in the race of improving performance on existing hardware are the cloud providers.
But they're also massive customers, so they will drive it.
Well, yeah, that's exactly right. But then again, even they have a kind of a perverse incentive, right? Because if you have to buy another, if everybody has to buy another server on average to recoup the performance they lost, they're not sad about that. So anyway, this is
now I have a headache. Good job.
The philosophy of vulnerabilities and InfoSec.
This is a depressing episode. We should put a warning label on this one.
Yes. Lock up your pills. Anyway.
Only listen to this episode with a furry critter on your lap.
That's right. Go to your happy place when this is over. So anyway, anything else you wanted to say about this? I think we kicked it around enough.
There's so many other folks doing such amazing analysis on this. I don't want to be redundant. There's so many great write-ups out there if you want to get into the nitty-gritty by a lot of good folks. If I start naming names, I probably would forget somebody I shouldn't, and so I'd feel bad. But there's just a lot of info out there, and I think it's still to be determined where this all shakes out. So I guess we'll have to keep an eye on it and try to bring something unique to the conversation that isn't being heard elsewhere. But
yep, indeed.
Not much else I can add.
Indeed. All right. Well, Happy New Year, and I guess we'll hopefully have much happier discussions next week. Maybe we'll talk about somebody that wasn't hacked.
Like your mom?
That really wasn't very funny, like normal. Yeah. So
I don't know. I just haven't made a your mom joke on the show in a while. So
okay.
My quota was new year, new quota. Ding, one done.
You gotta go ring the bell.
That's right.
Anyway, made a sale.
Oh wait, did we mention? We have not mentioned Hack in the Box.
Oh, that's right, Hack in the Box Amsterdam. Yes,
that's right. Our friends over there. I think Call for Papers may be just about to close or is already closed.
Yeah, it's conferences.hitb.org, I believe.
Yes. And we got a discount code.
Yes, defensive security. You get 10% off.
Yeah. So if you're in Europe or want to go, check it out. We need to get there one of these years.
Yeah, I'm still trying to figure out how I can get over there. Unfortunately, I've got a trip coming up to Dublin, and then we're going to Bogota, and then I'm taking a family vacation to Hawaii at some point.
Wow.
So I will have the frequent flyer miles this year. Anyway,
yeah, seriously.
We're wasting people's time now. So sorry about that. If you can find links to the stories we talked about on our website at www.defensivesecurity.org. You can follow the show on Twitter at DefensiveSec. You can follow Mr. Khaled on Twitter at Lurg, and me on Twitter at MaliciousLink. And with that, we will talk again next week.
Have a great week, everybody. Thank you as always for listening.
Bye-bye. Bye-bye.